Okay, Common Core Geometry kids, this is Unit 5, Lesson 5. Okay, what we're going to be looking at are the relationship between the corresponding sides perimeters and areas of similar shapes. Okay, we're going to start with a simple example, which will extend to everything. So let's say you have a 3, 4, 5 right triangle. And let's say you double the sides, and you have 6, 8, 10. So if we look at the sides, the ratio of the sides from, we'll call this the pre-image. Okay, this is the image. The pre-image is also known as the original, right? So the scale factor is image over original. IO, it's an Italian job, remember? Okay, so if we look at the scale factor, if I take the smallest side of the image and compare it to the smallest side of the pre-image, or the middle size side, or the largest pair of sides, you can see that the ratio is 2 to 1. So this is an enlargement. An enlargement is any time the scale factor is greater than 1, right? So let's look at the perimeters. So if we look at the original, okay, and we look at the image, and remember, original is the same thing as pre-image, okay? If we look at the perimeter is 3 plus 4 plus 5, which is 12. If we look at the image, the perimeter is 6 plus 8 plus 10. Now, if you think about the distributive property, I could just factor out a 2 here, and then you'll see that the perimeter is just double what it was originally. Okay, so the ratio for the perimeters, okay, the ratio of the perimeter of the image to the perimeter of the pre-image is 2 to 1. Okay, so that means that the ratio of the perimeters is the same as the ratio of the corresponding sides. Okay, ratio of perimeters of the similar shapes is the same as the ratio of the corresponding sides. Okay, so now let's look at areas. Okay, so you know that area is half base times height, right? So this is my base, this is my height, and vice versa, that's my base and height. So if I look at the area of the original, I get the area is half 3 times 4. That's just going to be 6. And then if we look at the area of the image, we get half 6 times 8. Okay, now the difference here is if you look at this 3, the 3 was doubled. If you look at the 4 was doubled. So the final area, okay, when you do this computation, is 24. But remember, this was the same as half 2 times 3 times 2 times 4. So if you look at this pattern, instead of the ratio being 2 to 1, okay, the ratio is 4 to 1. So the ratio of the perimeters, the areas of the similar shapes, okay, what you're doing is you're taking the original ratio and you're just squaring it. Okay, so it's going to be 4 to 1. 2 to 1 times 2 to 1, or 2 over 1 squared. Okay, so now you're going to have to memorize that. All right, let's take a look at some problems, some Common Core geometry problems on this. Okay, so you're going to pause the video and copy down this first problem. Triangle RJM has an area of 6 and a perimeter of 12. Okay, so this is triangle RJM. If the triangle is dilated by a scale factor of 3, centered at the origin, what are the area and perimeter of its image? Okay, so what we learned is that to get the image, since the scale factor is 3, we're going to multiply the perimeter by 3. But for the area, we're going to multiply it by 3 squared. Okay, so this would be your answer. All right, this would be the information for triangle R prime, J prime, M prime. Okay, if you look at the ratios, if you look at the image to the pre-image, right, you could see that the perimeters are in a 3 to 1 ratio and the areas are in a 9 to 1 ratio. So if you don't like the way that I explained it here, another way you could do it, if you could say that the ratio, okay, image to pre-image or original, whichever way you want to say it, image to original. Some kids prefer to solve this with a proportion. So this ratio is 3 to 1 because that's the scale factor. And then for the perimeter, you would have the image's perimeter, which I'll just call X, over the original perimeter. And then you could cross multiply. That's another way you could do it. And then you could do the same thing for the area, okay? Except that when you do, this is for the perimeter. When you set up your proportion for the area, the difference is going to be when you do the image over the original, you're going to square the ratio. So we get 9 to 1 equals the area of the image over the original area, which is 54. That's another way you can set it up. So whichever way you find is easier. Okay, so pause the video, copy down example 2. The ratio of the ratio of the corresponding sides of two similar squares is 1 to 3. What is the ratio of the area of the smaller square to the area of the larger square? Now make sure you read the problem. We want smaller to larger. Okay, so the original ratio was 1 to 3. So for the areas, you square that ratio. So it would be 1 to 9, smaller to larger. Be careful because they could word it differently. They could say larger to smaller, even though they gave you the ratio of the corresponding sides is 1 to 3. You would need the common sense to know that 1 to 3 would be 3 to 1 if we were talking about larger to smaller, and then you would square it. So just be careful with the reading of these questions. Okay, again, pause the video, copy down this example. Two triangles are similar. The measure of the shortest side of the first triangle is 12. And the measure of the shortest side of the second triangle is 5. If the longest side of the first triangle is 15, what is the measure of the longest side of the second triangle? So all you're going to be doing here is using CSSTP, corresponding sides of similar triangles are in proportion. So we're going to have first triangle to second triangle. You have to set it up. So we have shortest to shortest, right? So that's going to be 12 to 5. And then we have longest to longest, but they're telling us longest for the first, so we need the longest for the second. Okay, again, these questions are really going to come down to reading. And because you do have a calculator, you need to understand that they're going to expect you to do this on a calculator, all right? So I get 75 divided by 12, so I'm just going to make that 25 over 4, which is 6.25. Okay? All right, example 4. Okay, in example 4, the wording of the question is a little different. Given triangle ABC is similar to triangle DEF, such that AB, now remember what I've taught you, okay, and you could pause the video and copy down the question, of course, before you listen to me. Okay, so AB to DE, these are corresponding. So the ratio is 3 to 2. So that means the corresponding sides are in the ratio of 3 to 2. Okay, so now let's look at the first one. We're looking for what's not true. BC, does that correspond to EF? Yes. So that means the ratio is 3 to 2. Check. Okay, so that's not the answer. The measure of angle A to angle D. Well, corresponding angles are congruent, right? Corresponding angles are congruent, so that means they'd be in a 1-to-1 ratio. So therefore, this is not true. Okay, if you look at the other choices, the areas are 9. The ratio of the areas is 9 to 4. That's true because you square that. And the perimeters are the same as the corresponding sides. So those are true. Okay, so that's why the answer would be choice 2. This question you want to carefully study because they love to make this an alt. So just make sure that you always know that corresponding angles in similar triangles, corresponding angles are in a 1-to-1 ratio. Always. Okay, that concludes this video. Thanks, guys.